The endocrine system is made up of organs, tissues, and even individual cells that release hormones into the bloodstream. The function of the endocrine system is communication. We need to communicate with different parts of the body in order to coordinate and regulate the various processes of the body. The endocrine system is very important for maintaining homeostasis, for making sure our body maintains the internal conditions that are needed for its proper functioning. In order to do this, the endocrine system is involved in regulating a lot of different things, from growth and development to ion and nutrient concentrations, water balance, digestion, metabolism, and many more things. Before we get too far into the details of the endocrine system and how it works, I want to talk more generally about some regulation mechanisms. Most of the regulation in our bodies is through the process of negative feedback. And negative feedback, every time a body condition gets out of a set range, every time it gets away from normal, we activate mechanisms to bring it back to normal. This requires a few steps. First, some body condition has to get out of range. So let's say something in the body gets too high. We have to have a receptor to detect this. There has to be a cell or an organ that's going to look at this level and figure out when it's too high. When it detects that the level is too high, it activates mechanisms that are going to bring that level back to normal. This is the response, being able to bring that situation back to normal. That brings us right back to normal situation. Let's look at a specific example instead of general. Body temperature is regulated by negative feedback. As long as your body temperature stays in the normal range, everything's fine. But if something happens to cause your body temperature to increase so that you get too warm, the hypothalamus in the brain detects that the body temperature has risen too far, and it activates mechanisms to try and cool you down. Specifically, the hypothalamus will activate sweating, so that evaporation of that sweat can help cool the body. And it will also cause dilation of the blood vessels in your skin. That brings the warm blood to the surface of the skin where the heat can radiate out of the body, allowing the body to cool off. These mechanisms will cool the body, bringing the temperature back to the normal point. If it happens that you go outside on a cold day, you might get too cold. The hypothalamus detects that the body temperature is too cold and activates mechanisms to warm you back up. That includes shivering, which is quick little muscle contractions that release a lot of heat to help warm the body, as well as constricting the blood vessels so that we're not losing heat through the skin. These mechanisms raise the body temperature back to normal. Negative feedback is all about returning the situation to normal. Every time you get out of range, negative feedback brings it back to the normal range again. Most homeostasis in the body is regulated by the process of negative feedback. Anytime something gets out of range, we have mechanisms that bring it back to normal. Positive feedback mechanisms are a different story. With positive feedback, whenever a normal body condition gets a little bit out of the normal range, too high or too low, this is detected by a receptor, which then activates mechanisms to make it worse, to make it further from normal, which is then going to be detected and activate mechanisms that bring it even further from normal. Positive feedback keeps making the situation more extreme instead of returning it back to normal. There aren't very many things in the body that are handled by positive feedback, but there are a few. One example is the process of labor. Under normal conditions, there's no pressure on the inside of a woman's cervix, and nothing happens. When a woman is pregnant and very near to giving birth, the baby's head is pushing very hard on the cervix, and the pressure of the baby's head on the cervix is detected by receptors that send a signal up to the brain that cause the release of the hormone oxytocin. Oxytocin goes to the uterus and stimulates uterine contractions. When the uterus contracts, that pushes the baby's head harder against the cervix, which is detected by the receptors, which causes the release of oxytocin, which stimulates contractions, which makes the baby's head push harder against the cervix. And this positive feedback keeps leading to an increase in contractions and more pressure on the cervix until the baby is finally delivered. For women who have ever experienced an induction, what they typically do is they give you oxytocin through an IV. That oxytocin stimulates the contractions of the uterus to push the baby's head against the cervix, which hopefully will trigger this positive feedback loop to eventually lead to the delivery of the baby. The endocrine system is involved in both negative feedback and positive feedback.